Today's presentation, I really wanted to go over some stuff, not so much as fun and exciting as as Zach's presentation, but just something that I've seen recently with Particleworks support. As James mentioned in the beginning in his presentations, it's oftentimes easier to create problems than it is to solve problems. And so one of the major problems that I see, or at least one of the mistakes that I see frequently, especially with new particle work users, is defining the initial time step. So what happens is sometimes when I get a model from somebody and I ask them, okay, well, how did you come up with your time step? Somebody says, well, I don't really know. I just kind of guessed, or I just pulled the time step similar, from a tutorial model, and I think that's good enough. Well, in actuality, that's not true. There's a specific way that we should be calculating our time step, and our time step is calculated in such a way that we are meeting a current condition. And in this slide, this is just a basic definition of how this is being calculated inside of Particleworks. We're using our current number, our particle size, and our maximum velocity, um, either of a particle or a moving boundary, to calculate our time step. Now, with that being said, there is a recommended current value of zero point 0.2. Um, and what I'll do is kind of go over what that actually means in the next slide, because as I was working, becoming familiar with Particleworks from day one, I kind of had questions like, what the heck is are they talking about this current number and current condition? So what the current number is, it's just a non-dimensional number that describes how quickly information propagates through space. I ended up making like a small diagram to the right, and this to me does a really good job of explaining why this is so important. Because if our time step is too large, then what happens is we allow information to travel too quickly through space, and through space. And so sometimes whenever I've seen customer models, they come to me and they say, "Well, Chris, my particles are exploding, or they're going beyond wall boundaries, and that's not supposed to be happening." Well, what's happening here is because we've defined our time step to be too large, and we're allowing particles to travel too quickly through time, or excuse me, through space. So we'll see unrealistic behaviors such as particles passing through walls. So for mesh-based CFD, a current value of 1 just typically means that a point in the fluid will travel across one element in the time step. This is pretty similar to what's going on in Particleworks. The only difference is we're defining the distance between particles, and we're using that initial spacing to set up this current condition. Again, the recommended value for this current number is going to be zero point 0.2. Uh, Particleworks allows up to 1 just for numerical stability. And what I ended up doing was to kind of test this out a little bit. I took a tutorial model, um, and I tried to make this a little bit more apparent visually. So on the left hand side, this is just a tutorial model just to kind of get your hands on Particleworks, become familiar with it. Not really a whole lot of importance to the time step in this particular model. Again, we're just really just trying to get a quick overview and figure out what's going on. What I ended up doing was I ended up using the gear speed of this particular tutorial model, and I fine tuned the time step a little bit to get it to what I would consider to be quote unquote more accurate if I was working on a production model. Um, you can see here that there's a little bit of a difference. It's not too much of a difference, but there can be a situation where you define a time step that's too large for a model, and you can get some simulations. Um, just know that they may not be accurate 100%, especially if we're working on production models. Again, this is just a tutorial model, so it doesn't really matter what we do for the time step. We just want to get the point across of how to use Particleworks. But I feel like this is a good representation of what can happen whenever we set time steps that are too large. And just kind of as we're looking at these, I always like to keep on my workflow, or at least my process. The smaller my time step is, the better it's going to be out for me in the long run. This is an example of that same tutorial model where I looked at the task window. If you look at the distance, or excuse me, the initial time step, that time step is not constant. It's constantly changing, and what it's doing is it's adaptively changing throughout the simulation to maintain a current condition of point 0.2. And so what's happening is as the particles accelerate, the time step has to change. So as the velocity goes up, time step has to go down. So that's what we're seeing here. Excuse me. In this particular example, again, if we were to run this model and we saw that it completed successfully, we can start taking a look at results. But I always like to keep on the back of my mind that if my time step isn't consistent all the way through, then there may be an issue. It may be okay, but I would like to go back in and double check it, either with engineering analysis or engineering evaluation. So there's a couple of cautionary steps I like to take. This next example is what happens whenever we have a consistent, smooth, what I like to call smooth time step throughout our entire simulation. Ideally, this is really what we want to be seeing when we're running your simulations. This tells me that I'm not seeing any erratic behavior and velocity. I feel more comfortable with my solution being accurate, and I know that I've done everything that I can to make sure that there's nothing uh, set up incorrectly with my time step. This is just an example of what happens if it's too large. If the time step is too large, the simulation will crash right away, and you won't even be able to start anything. So if you get this error, that's typically what that means. And because we're running a little bit out of time here, I've put together some common questions and troubleshooting tips as I've been working with Particleworks models more and more recently. I'm not going to go over these in great detail, but if anybody's interested in these, we will share this. Or I will share this slide deck. Take a look at them. But just some of the common questions that I've seen, is how do I set it up? Um, how do I set up the time step? Like the best way I can think of is sometimes it's a trial and error process. We got to take a look at things like our fastest particle speed, or we have to calculate a speed based on a moving boundary. For gearbox applications, that's pretty easy. We've got a calculator for that. But if we don't know those particle speeds, then typically a trial and error process is usually the best step. Um, and a little bit I want to touch on here is just the current and velocity limiters. That information was kind of discussed in a little bit in our first tips and tricks session. So I highly encourage those to go back and watch that if you have some questions on that. And then few more um, few more questions that I've gotten. These are just again just various questions that I've seen as I've been working on support models. Um, if there's any questions about your particular model, and if you're setting the time step up right or you're setting the problem up right, and you're not sure, you can always send us an email. You can always send it to the Zoho desk. We'll be glad to help you out and you know help you get set up on a path forward. So that's my presentation for today. Thank you everybody for listening. I will turn it over to the group, and we can open up to a quick Q&A before we leave.